All right. Okay, so for those of you who are on Zoom, if you did extra credit, please remember to email me your work. All right. Okay, so we talked about the strategies for integrating some special sine and cosine combination. Okay, most of the time, the powers, they're integer powers, but sometimes the strategy also works when you have roots and stuff like that. Okay, just remember, if you want to use some sine, think about what you need to have for cosine to make it happen, right? We went through the process. And similarly, if you want to use some cosine, what analyze the powers of sine and see if it works. Okay. And the important identity to convert between the sine and cosine, the sine squared plus cosine squared. Okay, but remember, every time you get two, right? The even number. So that's super important. So let's look at this one. Cosine. Okay. So well, if you did extra credit, you probably figure out what to do. And if you didn't do the extra credit, can you look up your note and you figure out, is it a sine sub or is it a cosine sub? Or you can think, process the information, right? If I want a sine sub, what needs to happen? If I want cosine sub, what needs to?
Why like a cosine stuff? Because it just like the cosine.
So if you want a cosine sub, how many sine do you need? Du, right? When you differentiate cosine, you get sine, so you will need at least one sine to make it work. And do we have any sine? No, so every time you convert cosine, how many do you get? Two, so it doesn't work.
You mean you said sine?
You actually want to use sub sine. Okay, why is that work? If you want to use sub sine, you will have at least how many cosine? First, you need one for the du. And then you take one out for the du, how many cosine left? Two, even good. So you can make that happen, right? See, if you just analyze those through the process, count the numbers, you will figure out what will work and what will not. So this one is actually sorry. Okay, so remember, if you are able to analyze, it's much better than trying to memorize something without knowing what's going on. Because you memorize, you may not know how to apply. So you want to analyze. If you're able to analyze it and figure out what's going on, that means you know the concept, you're applying it. Okay, so we just pretty much figure out the strategy. We said we want to do sine sub. So we need to reserve one cosine to go with dx because that's the u sub, the du part. And since we want to use sub sine, we reserve this one, right, for the du part. But these two, we have to convert it to sine. So now we're set up to do the new sub. With respect to u. And then we'll back up to sine x over two. Okay, so remember you wanna analyze first. So if you go through that analysis a few times, then you can handle it, you'll get it. Okay, try not to look up your notes and figure out even an honest search for the answer. If I should give you use of sine or use of cosine. If you were late, did you do the extra credit?
Oh, yeah.
You did? Did you get the-
Uh,
Right, so no matter how much you learn from school, it's never gonna be enough when you go to work. You always have to learn from the job. Okay, so what you're learning right now, most important part is to be an independent learner. Which means if you have to look up some reference stuff when you're at your job, and you need to learn something new. And nobody's gonna give you a lecture, explain to you what you're reading and all of that. You have to read it and figure out what it says and then apply to your job or whatever you need to do. And if you're on your own, right? Colleagues may give you a little hint here and there, but nobody's gonna show you with detail exactly what to do because they have their job to do. Okay, so to be an independent learner, that's what you're trying to become. All right, let's look at F.
you can do it both ways, both use of.
Okay, that's correct, because the two numbers, those are odd, so you can do either use of sine or use of cosine. I know a few of you did the actually, right? You do use of sine or use of cosine.
Subside.
You did use of sine,
Yeah.
you did use of cosine. Do you see how you did the use of sine? Okay. So the question is, which one is easier to do? Did you think about that?
Yes,
So you think it's easier to use sub sine?
yes.
Okay, when you use sub sine, don't you have to cube something out?
Yeah. But with use of cosine, you have to deal with the negative sign.
But the power wise, algebra wise is a lot easier. Okay. Okay, so this is actually easy.
Oh,
So next time, if both power work out, you wanna use up the one with the higher power, because that will make your algebra a lot easier. Okay, so let's do the use of cosine first, right? And then do the use of sine. But I will finish it, because you can tell it's a lot harder, but it's just the algebra part, okay? So. Okay, so we're gonna use some cosine. So we can reserve all the cosine, but we need one sine to go. With the dx. Okay, try to get ready. With the du part, right, that's why you think of your u, you have to think of your du right away, it's always a pair. Okay. And then we have sine squared left, and we have to convert it to cosine. Okay, it is true that when you use a cosine, you deal with a negative sign. So sometimes, yes, sometimes we choose use of sign because you don't deal with that negative number. You're absolutely right. But I don't think it's this is the case, all right? Because the algebra part is a lot simpler. So I think you're more willing to deal with just that negative sign instead of the algebra. Right, so, so you will have what, 1 minus root squared, and then give to the 7, and then right? Yes, you do have a negative sign in this case, but look, you have to square anything or cube anything, the answer is no. When you do the other one, yes, but then I think you have to cube it, right? That's a lot harder. Okay, so it's equal to 7 minus 9. And integrate, but this one is interesting. Depending on if you want to use a sine or use a cosine, the answer will look completely different, because one will be completely in cosine and one will be completely in sine. Okay, so we use a cosine, so this one is completely in terms of cosine.
With
Oh, I dropped the negative sign thing. Okay, now let's try out, what if we want to use a sign, right? Just so you can see both ways. Okay, so if you want to use a sign, same strategy, but the other way around, you keep all the signs. Okay, you want to break off one cosine to get ready for the du part. Okay. And cosine to the 6 is cosine squared and then cube, right? So it's 1 minus sine squared. That will give you cosine squared, and you cube it, you get the 6th power. So the advantage is we don't have to deal with the negative sign. Well, you do have to expand this cube, unless you remember that formula. I think it's 1 minus 3u squared plus 3u to the 4th minus u to the 6th. With minus, it alternates the sign. Otherwise, if you have to work out that cube, it's a lot of work. Okay. But if you have the formula handy, that's okay. Let me double check. Minus plus minus, yeah. So that part depends on whether or not you know the formula. If you know the formula, not bad. Otherwise, it takes quite a few minutes to actually get the answer. Okay, and then you want to distribute that Q. So this time your final answer will be all in terms of sine. So if you work together and compare your answers, just be aware that you do trade integrations, you may have different ways to approach it. And just because the final answers don't look the same, doesn't necessarily mean one of you got the incorrect answer or something like that. Gotta look at the process carefully. So if both way will work, try to use up the one with the higher power. It's just because the algebra part later on after you sub it's easier. Okay, good. Okay, so this one, if you look at the power,
Did we apply to this?
yes. Okay, because they both odd numbers, 3 and 3. So you can use up sine, use up cosine. And because they're of the same value, you can also do the double angle formula and make it in terms of sine as well. Okay, and this one is interesting. You use 3 different ways, then you get 3 different looking final answer. Okay, so in this case, because the power the same, you want to use up sine, that's the preferred way because you don't deal with the negative.
I think I just prefer the subs. It's easy.
Okay, next time I make the cosine power higher.
For D, you just apply it and then just switch the value.
Yeah, so let's do D first. Right. So that is a choice to apply. And again, it's personal preference. Some people just say, oh, I'm gonna do the use of sine because they feel more comfortable. That's totally fine. Okay, so this way, basically, you group the sine and cosine together because they have the exact same power. And then you apply that identity in D. Okay, so at this point, you already double the angle. So when you cube it all out, you have a constant 1/8. And then you have sine cubed. Okay, and this one we use of cosine at this point. Okay, so we break one sign off and change the other two to cosine. At this point, we use up cosine 2x. Oh, my bad. I copied it wrong. When I doubled it, that's x over 2.
Like,
Because I double x over 4, you get x over
yeah,
2.
what?
Okay, so you double the angle, but you double the x over 4. So your answer is in terms of cosine of x over 2. Oh, sorry, 1 over 4. All right, but if you use up sine or use up cosine, your answer will be in terms of either sine of x over 4 or cosine of x over 4. So this one, you can do 3 different ways. Depending on what you do, your answer will not look the same at all. So let's try one more because we have space for one more. Let's do the sine sub then. Okay, so if we do the sine sub, we keep all the sine. Right? And break one cosine for the du part, we have 2 left. And we're gonna do the sine sub. So in this case, because they have the exact same power, you can do sine sub or cosine sub. So in this case, use of sine is better because you don't deal with the negative sign. Okay. Because the process is almost identical, you just reverse everything, right? One you do in terms of sine, the other one you do in terms of cosine. Same strategy. Okay, and then you distribute that power u cubed. So it's pretty easy to integrate. So I'm not gonna do the use of cosine, but I can give you the answer if you do use of cosine. The answer is exactly the opposite. So this is the case where you can see, depending on what approach you decide to do, and then the final answer looks completely different. But as you can see, the foundation for this kind of problem is actually use substitution. So if you have solid skill for use substitution, it's easier for you to figure out what to do. So we figure out, we practice, right? We figure out and practice the sine and cosine integration. And then now let's talk about tangent and secant combination. But the way to analyze it is exactly the same, like how we did with sine and cosine, because you just count the numbers, right? You know, what if I want to do tangent sub, then what need to be there to make it happen, right? What if I want to do secant sub, right? What expression should be there to make it happen? Okay, it's still based on the use substitution skill. Okay, so if I want to do tangent sub, right? And what's du then? Secant squared, good. Because we always think about du right away. So that means we need two secant x to go with dx. Okay, so if you just have one secant, never mind. Tangent sub already doesn't work out. So if you want to do tangent sub, at least you should have two secant to begin with. Okay, so if you only have one secant there, the tangent sub would not work. Because you can convert tangent to secant, but every time you convert, you get what? You get two at a time. So it's never gonna, the number is not, it's not gonna work out, right? Okay, so if n is 1, use of tangent will not work. Okay, and if you only have two secant there, if n is 2, then you don't have anything extra, so it's like the perfect setup, all right? So I'm not gonna talk about that case, but what if n is greater than 2? So you have leftover secant. Okay, so if you have leftover secant, so we need to convert the extra. How many extra? It's n minus 2. Okay, so we need to convert that, the extra secant, to tangent using which identity?
1 plus tangent squared.
Yeah. So secant squared x is 1 plus tangent squared. Okay, so again, every time you need 2, 2, 2, 2, 2 to make it happen, so n minus 2 better be an even number. So it works if n minus 2 is even. Okay. All right, so if n minus 2 is even, what about n? Even or odd?
Well,
Even. So this means if n is even, we use up tangent. Right, it's the whole theory, the whole analysis is just based on use up. What we need to do to make it happen. So if n is even, then you use up tangent, it will work. Okay. So now let's see, what if we want to use up secant? Okay, let's try out. So if we let u to be secant x, okay, so first immediately we want to think about du.
secant tangent.
Secant tangent, okay. So we need one tangent. To go with the x. Okay, so if you just have exactly one tangent, it works out perfect. Thank you, sir. Right. But what if, so let's write down, so if m is 1, it works. So what if m is greater than what? If m is greater than 1, we have what? We have leftover, we have leftover tangent, all right? So we need to convert the remaining tangent, so that's m minus 1, to secant. Okay, and using the identity, so it's the same, but you just put a different order, right? Exactly. So tangent squared x is secant squared x minus 1. Okay, so again, every time you need 2, 2, 2, 2 to make it happen. So we need m minus 1 to be even. Okay. Okay, if m minus one is even, m is what? Even or odd? M minus one is even, you add one to it to get m, that has to be odd. Okay, so if m is odd, use a secant. Right, so the foundation is just based on new substitution, what we need to make it happen. Okay, so hopefully when you get a problem, you reason, right? You think the same way. Okay, what if I want to use a, try not to memorize the number, okay? All right, so what if you just integrate tangent? So n is 0, there's no secant there, right? You just integrate tangent. Okay, so if it's just one tangent, we know how to do, right? We even have the more general formula, right? So hopefully it's on your cheat sheet, right? You just had your exams. Let's do the more general formula. So when we integrate tangent, what do we get? Let's have the exam. Or something, I think something. Vaguely remember.
Something over.
Negative 1 over k. Okay, negative 1 over k.
Isn't there two of these?
Two of these, yeah, that's one of these. Start if you.
Okay, natural log,
Uh-huh.
absolute value of secant kx.
Yeah, that's the positive one.
Yeah.
If you do the negative one, it's the cosine, yeah.
Yeah.
So if you just want, you just apply the formula. I gave you the more general one. Okay, so what if m is 2? If you integrate tangent squared. I actually gave you the strategy as well before.
Secant squared k kx minus 1.
Yeah, you change it to secant because you know how to integrate secant squared.
I did.
Okay. And then you continue because you know how to integrate secant. But that's the first step. You want to convert it to secant. All right. So what if now m is greater than 3? Okay. So this is the strategy is almost like it's like a recursive procedure. So what you want to do here, you use up tangent. Okay, so notice that this is the more general technique. Notice that it just talk about m is greater than or equal to 3. It doesn't say if m is even or m is odd. It just says as long as m is greater than or equal to 3, you can use the strategy. And what strategy you use? It's pretty much this strategy. Okay, you take out 2 tangent, convert it to secant squared minus 1. Okay, so you take out 2. And why do we want to do that? Well, remember we just talked about use of secant squared can help with tangent use of. So remember, we want to use up tangent. Okay, so we need tangent secant combination. So we want to distribute at this point and separate it to 2 integral. Okay, so this first one is a perfect setup for tangent sub because it does have exactly 2 secant to work with, and that's the du part. And this one, you apply the same strategy. Okay, so this one you use a tangent. So for this one, if n minus 2 is 1, you do that. If it's 2, you do this. If it's greater than or equal to 3, you use the same technique all over. Okay, so all the techniques that we derive here is all based on U substitution. Okay. All right, so what if we just integrate powers of secant and that's it? So for 1 and 2, we have formula, right? Okay. So if we integrate secant x, that's what n is 1. Oh, let's do the more general one case. Okay, so do you have this formula on your cheat sheet?
Secant kx over k.
Okay, my bad. This is from 8.1, so it's not on your cheat sheet. Okay, but if you get 2, this one you know, right? So this one you get tangent. Okay, so if it's 1 or 2, we know exactly how to handle. We can apply the formula directly. Okay, it gets interesting if n is greater than equal to 3. Okay, but this time we break it up to even odd. Okay, if it's even, if it's even, we use up tangent. Okay, so remember this is even and greater than equal to 3. So use up tangent. Okay. So if we want to excuse me. So if we want to use subtangent, we need 2. To go with the du. Yeah, dx to complete the du. Okay, so at this point, n minus 2 is still even. So we convert the rest of that to tangent. Okay, secant squared is 1 plus tangent squared. Okay. And u subtangent is set up. But this time, if n is odd, you have to do integration by parts repeatedly, which is not fun to do. Okay, so if it's odd, and then this is the time you're allowed to use this reduction formula. Okay. So if it's even, you go through that strategy. Okay. And whatever we just talked about with tangent secant combination, you mirror it to cotangent cosecant combination. Okay. And you can use this reduction formula if n is greater than equal to 3 and it's odd. All right. Okay. So there are 6 reduction formulas like this. So you have sine, cosine, tangent, cotangent, and secant, cosecant reduction formula like that, right? So all of those you're not allowed to apply because we want to check whether or not you are able to apply the integration technique. So if you reduction formula for sine, this is the only one you can use. Reduction formula for cosine, this is the only one you can use. These two, you can only use it if the power is odd and greater than equal to 2. Everything else, that means you have to apply the strategy, right, that we talked about. Okay. And all these strategies that we talked about based on what? Just use substitution, one technique. All right. So let's practice. So we integrate just the tangent based on what we just talked about. Can you figure out, right? The one you know to rule out immediately is to apply the reduction formula because it doesn't work. Okay, you're not allowed to use that. So it's either tangent sub of secant sub. Which one will work?
Use
Right. So again, you can
Sub.
reason, right? If you want to use subsecant, there is no secant. And then du, you need a secant tangent combination. So it's all number doesn't work out, right?
subtangent.
Yeah, so we actually use subtangent. Okay, so this is a concrete example. We talked about the strategy just now. Let's do one concrete example, okay? So u subtangent, and the du is what? Secant squared, so we gotta take out 2 of the tangent because we need to get ready for the u substitution. Okay. So we break 2 off. and change the tangent squared to secant squared minus 1. So at this point, we split this into two integrals. So the first one is a perfect setup for U substitution. Okay. And the second is an integral of tangent alone. Okay. But power is 2. We talked about the strategy. What do you do with power 2 for tangent? Yeah, apply the identity. Okay. So the first one, we have it set up perfectly for the U substitution. For the second one, because it's squared, we convert it to secant squared minus 1. Okay, don't need U sub for the second part. So now we are ready to integrate. Okay, so when we integrate secant squared, we get tangent. Okay, so one more step. Okay, so this is a concrete example to demonstrate the strategy that we just talked about. Okay. Okay, B, we integrate just the cosecant. Okay, this one, remember we talk about what? We talk about the strategy for integrate just the secant. Okay, right here. Okay, so if it's even, and this is the strategy how to handle the integral of secant. Can you kind of mirror image it? This will integrate cosecant to the 6th power, which is even. So that's the strategy to use, but you have to do it with cotangent, cosecant combination, right? So try it out first before I give you the answer. So this is what you have to do now, right? You're gonna apply that, but mirror image it to secant and cotangent. I mean cosecant and cotangent, right? Okay, so let me put the strategy here. It's easy for you to make the reference, so you don't have to flip the page. So you want to mirror image it now because now you do the cosecant. Mm-hmm. Okay, so it means you want to use up what? Coltan. So it's the exact same strategy, but you do it in terms of cotangent and the cosecant. Okay, so let's try that out. We want to use cotangent. So we need two cosecant to go with the dx. So we have 4 left. 4 is square squared, right? Okay, so we break 2 of the 6 to go with dx, set up for the du. And then 4 left, we write it as square squared because we want to use the trig identity to convert it to cotangent. So that's 1 plus cotangent squared. That will give you cosecant squared. Okay, so now we are ready for the u sub part. We u sub cotangent. Right, so the du will need 2 cosecant to go with the dx. Okay, so now we completed the u substitution. And we just have to work out the square part and then integrate term by term. Okay, and then we distribute the constant -2, yeah. Okay, so all the strategies that we talked about, for tangent and secant, you can mimic that, for cotangent, cosecant combination. So if you're done with this one, look at the next one and decide, if we're gonna do a tangent sub or a secant sub. Okay. So how about you, get started to apply the strategy that we talked about first? So C, use of tangent or use of secant? Figure out.
It's
Okay.
uh, it's and more and negative. Yeah, and
Yeah, because if you use up tangent, you will need even number of secant to make it happen. Okay. So you use up secant. All right, so now we know for sure what to do. Get started. All right, see if you can apply the strategy that we talked about, before I gave you the steps. Let me try out first without copying what I have, right? That you will remember what to do much, much better.
Also, just in general, minus two. Let's see, as I both of them are minus two.
That's why in practice you figure out what part.
That's why something fell off.
Still, yeah. Okay. See, if you process the information, then you have the menu that tells you what to do, and you have to figure out exactly what the menu said and put it into practice. That part is the learning process, learning part. And it's okay if your first attempt, it's not quite there yet, but you thought about it, you practice that information, right, the strategy, so you actually already learned something. So we want to do use of secant. First, what's the root of secant?
Secant.
Secant tangent. Okay, let's first make sure we do have a secant tangent to work with later on. So I need one tangent, one secant. I'm gonna reserve that for the du. So I have now two tangent left, two secant left for the use of part. And since I'm use of secant, I gotta convert that tangent to secant. So the tangent squared is secant squared minus 1.
Okay. Yes.
Right? See, after all these examples, you should figure out, we want to make sure the use of substitution will work out. You always reserve what you need for the cube. Right? Right, you already figure out what's gonna be the use of. Right, either tangent or secant, based on your decision, you reserve the part for the du. Okay, the constant may be off a little bit, then you can work on the constant later. Right, the main structure, you want to preserve it. So we use a secant. Right, so the constant may be off a little bit, but we can work with the constant easily. It's the main structure, the secant tangent part, you wanna make sure that you actually have it to work with. Right, see, that's why I emphasize, okay, I gotta have the tangent, because I need it for the video. Okay, so we have u squared minus 1, u squared. And we distribute the power. And we integrate term by term. So nowadays, the technology has advanced so much, right? It's not difficult, say, if you go to work later on, you find a job, something you don't know what to do, and then you Google it, you find the so-called instruction, right? Tell you, okay, what you can do to reach your goal. But then, see, the part that's missing is your instructor showed you an example how to apply that value instruction. You have to read it and figure out on your own, like, okay, for my job now, what I need to do to get it done. Right, so it's more important to practice that skill. So you wanna be able to learn on your own. That's my point. So all these little exercises is like mini practice, mini practice. Okay, so whatever you learn from class are never gonna be enough. You go to work, you gotta learn something. Okay, especially when you just get a job, pretty scary. To be honest, right? I have students tell me, oh, they gave me a stack of books that I have to read to catch up on the project or something like that. Who is there to help you figure out what the books are saying? You yourself. Maybe a friend or two, but you're the one who carried the weight, right? Okay, next one. All right, okay, so this time is a cotangent cosecant combination, but we talk about tangent secant combination. Can you mirror it? Apply the strategy. Okay. So first figure out, do you want to use up tangent, cotangent, or do you want to use up cosecant?
Oh. Um,
Okay, so we can use up cotangent, that's good. Can we use up cosecant then? Does it work if you wanna use up cosecant? Yes, so this is the case where this will do. Okay, but which way will make the algebra part a little bit easier? Yeah, you pick the one with the higher power to do the research. So the algebra part will be easier, although both ways will work out. Okay, so how about you try use of the cosecant with this one, because the algebra is easier. It's actually very similar to this one that we just did, because that's a tangent secant combination. And we use up the secant, but this time we want to use up the cosecant, right? So hopefully after C, when you do D, you have more confidence of exactly what to do. But I think most of you are doing really well. That's awesome. So we decided to what, use up cosecant. So we need to reserve one cotangent and one cosecant. For the du part. And then this cotangent square will have to convert it to cosecant. Right, so everything's set up. So we use up cosecant. And remember, we have a negative sign this time. Right, so it's really similar to just that one. See, that we just said. It's just different powers, so the algebra afterwards will be a little bit different, but the strategy will be exactly the same. So to you, maybe these two are two different problems. But for your teacher, because it's the exact same strategy, so it will be considered as the same type of problem. Okay, next one, what's the strategy? Reduction formula, okay, so apply the reduction formula. So let me go to that page so you don't have to flip your pages. So here, reduction formula, right? So are you able to apply that formula? Do you understand what's going on? So I'd like you to try first. Okay, that's the formula number 3 to apply to that problem. So do you understand how to use it? So give a try first, okay? Okay, but for this one, I like to use use up first. Okay. Because you cannot ignore the x over 4, right? So this is the reduction formula that we're going to use.
Oh.
So you cannot ignore the 4, pretend that it's not there, and apply the reduction formula with x over 4, x over 4, x over 4, right? So you have to take care of that. And now I can do it. Okay, so 4 times the quantity. So n in this case is 5. 5 minus 2 is 3. 5 minus 1 is 4. Sorry, my bad. Okay, so that's the first application of that reduction formula. What n is 5. And then we do second round application of the reduction formula. This time n is 3. 3 minus 2 is 1. 3 minus 1 is 2. Okay, so this is okay, and then last one we apply the integration formula directly. So that's ln absolute value of secant u plus tangent u. Okay. So if it's not just a clean variable x there, you may want to do a use up first. Yeah, did I get it?
Did the 1/2 come from on the last two?
That's n is 3, right? 3 n minus 2 is 1. 3 minus 2 is 1. 3 minus 1 is 2. Did I use it correctly? This one?
Oh,
So you have to use it one more time.
oh,
There's only one and two we can do. Anything higher than that is, if it's odd, then it's reduction. So you use reduction formula once, right? So from here to here, right? Here we use the reduction formula.
so the denominator then is like n minus two.
Yeah, three minus, denominator is n minus one, so three minus one is two.
Oh, the numerator.
Yeah.
Oh.
So this one is reduction formula one more time. But this time n is three. Right, so n is five here, and then n is three there. And if you're done with this one, we have one more problem to look at it. What can we do for the next one?
Three.
So can we use a cotangent? Can we use a cosecant?
That's your right.
Okay, use a cotangent, we'll need two cosecant, or at least it's even, we don't have. If we wanna use a cosecant, we need this number here to be odd. And it's even, it doesn't work out. Okay, so direct use of doesn't work out, what else can we do? Don't just stop there and say, okay, use of doesn't work out, and then say, no solution or whatever. But it can be done here. Okay, reduction, yes, but before that, you have to do a little trick. What's the only thing you can do right now? If you have to do something, right?
Pull out. Okay.
Cotangent squared, what's that trigonometry related to cosecant?
It was to be of okay. See.
Yeah. That's the only thing you can try. This use of at this point doesn't work. But you're asked to integrate. And that's the only thing that's familiar is cotangent squared. Okay, so cotangent squared is what? Cosecant squared minus one. Okay, so all the strategies that we talked about that covers a lot of cases of the trig integration, but doesn't mean like this one, right? First glance, nothing works. Okay, so that means you have to do something else first to reach to a point that we are familiar with. Okay, so the only thing we can try is to play with the cotangent squared. And if we do that, what do we get? Cosecant cubed, and then cosecant, right? Basically two separate integral. Cosecant, we have formula. You can do it right away. And what do we do with cosecant cubed? Reduction formula. Yep. Okay, so this is the reduction formula for a cosecant. That's the reduction formula. So this time n is 3. So it's negative cosecant x cotangent x over 2 because n is 3 plus 1 over 2 cosecant x dx. And we have another cosecant x dx. So before we integrate that, let's combine. Okay, so we have positive 1/2 of this integral minus 1 of that integral, so it's negative 1/2, right?
It is,
So you can, it's like combining similar terms. So you can put those two together before you apply the integration formula. Okay, so that one is that one has like 3 different formulas. Okay. So next section, we have more trig integration. So this becomes the foundation now. Okay, so review the strategies that we talked about so far from 8.3 before Thursday's class, because we're gonna learn more. Like, it's like, we gotta do some steps first and then reach to this point. And then apply these strategies. Okay, so review that first before Thursday's class. Okay, so give me a few days to work on grading your exam. Okay. All right, have a good one.
you could